Welcome to the physics solution, and in the discussion that a reflection of light in part 1, already that we have completed the discussion that is how reflection taking place from a reflecting surface. And today that we will take the discussion that about the laws of reflection of light and also the properties of a plane mirror and also how reflection is taking place from the surface of a spherical mirror. So, reflection of light means that while a ray of light that returns back or sends back to the same medium after striking to a surface, that is called the reflection of light. And while that we have taken the discussion that about the reflection of light through a plane mirror, suppose that this is your plane mirror and it is the incident ray and this is your reflected ray, this is your normal, and here that this is your object and this is your image, this is your point of incidence P and this is your plane of incidence XY, and the angle between the normal and the incident ray, that is the angle of incidence I, and the angle between the normal and the reflected ray, that is the angle of reflection R. So that after taking the expression that how reflection is taking place through a plane mirror, that we can write the laws of a reflection of a light. And in the reflection of light, that there are two laws. And the first law, that the incident ray, the reflected ray, and the normal, that they will lie in one plane at the point of incidence. This is your first law in the reflection of light. The incident ray, the reflected ray, and the normal, that they will lie in one plane at the point of incidence. And the second law of reflection of light, that the angle of incidence I, that is equal to the angle of reflection R. Angle I equal to angle R. So that these are the two laws of reflection of light. And also in part 1 of the reflection of light, already that we have taken discussion that about the formation of an image. Means a ray of light that is coming from the object O, taking reflection at the point P. If the ray of light that will meet at the point I, then I is the image of the given object O. And again, the image form that is of two types. That may be either that may be real image or that may be virtual image. If image that can be observed that on a screen, then such image that is your real image. But if any image that appears to produce at a given point, then at that time that image produced, that is a virtual image. So that these are the two laws of reflection of light. Now that we will take the discussion that about the properties of a plane mirror. Properties of a plane mirror. So that this is the surface or it is the ground. Suppose that we have taken a plane mirror. This is a plane mirror. The back surface, that is the color polishing surface. M that represents the plane mirror and it is placed vertically. Suppose that we have placed an object here named as a B. And if the object that is at the front of the plane mirror, then the image that will be produced behind the plane mirror, and here the image that will form, named as A dash, B dash. A B is your object, A dash, B dash, that is the image formed by the given plane mirror. And here this is the object and this is the image. And the image formed by a plane mirror, that is virtual. So that we have given the dotted line. While that we will get the real image, then that you have to draw a clear line. But while the image that is virtual, then at that time always that you have to draw the dotted line. And this is the position of the object and this is the position of the image. And it is the object distance from the mirror to the position of the object, that it is the object distance, and it is represented by U. And this is the image distance This is the mirror and this is the image, so that this is the image distance, and it is represented by the letter B. And in case of a plane mirror, that is the object distance that is equal to the image distance. It is one of the property. And another, if O, capital O, that represents to the height of the object, and capital I that represents to the height of the image, then another property of a plane mirror, that the height of the object that is equal to height of the image. Height of the object O equal to height of the image I. And object distance that is equal to image distance. It is number one, height of the object equal to height of the image. Number two, object distance equal to image distance. Number three, the image formed by a plane mirror that is virtual and erect. Number four, that the image formed by a plane mirror that is laterally inverted. तमाने आमे प्लेन मिरर आगे छिड़ा ही जदि आमर राइट हैंड आमे रेज करेबा तले तमे देखिबो से मिरर रे तमरो इमेज तारो लेफ्ट हैंड साइड रो हैंड से बा लेफ्ट हैंड से राइज करिवो तमाने तू जणा पडिला कोन जे द इमेज फॉर्म बाय ए प्लेन मिरर दैट इज लैटरली इन्वर्टेड ओलोटा so that it is also one of the property. And since object distance that is equal to image distance and the height of the object equal to height of the image, so that their ratio that is equal to 1. If these two distances are equal, then this by this or this by this, that will be 1. So that the magnification produced by a plane mirror, that is 1. Because the magnification is equal to height of the image by height of the object, or size of the image by size of the object, and the image distance divided by object distance. And here, since in numerator and denominator that both are equal, so that ratio that represents to the magnification of the given plane mirror here, which is equal to 1. So that and another property of the given plane mirror, that here you see, already we got here, or we have taken the discussion here, that object distance equal to image distance. Now object distance by time, that is equal to image distance by time. It means if an object will move with a speed u, then its image also that will move with the same speed u toward the mirror, and with the speed of 2u toward the object. Because these two distances are equal. A distance जहा A distance तहा तलो तेरे A distance by time कहलो speed, A distance by time कहलो speed. तामने object ता जितनी की speed रे mirror आड़ को जाऊ थी वो ए image रा मध्य the same speed रे से mirror पाक को आसी. किंतु mirror पाक को सिना से same speed रे आसी वो किंतु object पाक को कितनी speed रे आसी कहले जाके we have to take its double distance. So that the speed that will be double. Calculation while that will take here, then it will be double. And another property of the given plane mirror, so that we have taken two plane mirrors. These are the two plane mirrors. Let it is a mirror M1, it is a mirror M2. And the angle between the two plane mirrors, let that is theta. And suppose an object is placed here. And to obtain how many number of images that will form by this object means that we have a certain formula. जदि दीटा प्लेन मिरर भितर गोटे ऑब्जेक्ट एठी अछि बा तमे मने करो छिडा हिच तमे जे कोनसी मिरर को तमे जदि देखिबो ताले तमे तमर केतेटा इमेज ऑब्जर्व करि परिबो कहिले ता पई फार्मूला होछि दैट n इक्वल टू और नंबर ऑफ इमेजेस प्रोड्यूस्ड बाय एन ऑब्जेक्ट दैट n इक्वल टू 360 बाय थीटा माइनस 1. For example, if theta will be 60 degree, दीटा प्लेन मिरर भितर जदि एंगल ता 60 डिग्री हेतिबो ताले केतेटा इमेज प्रोड्यूस होबो एठी गोटे ऑब्जेक्ट रखिले कहिले 360 बाय 60 वाला 6 माइनस 1 दैट इज इक्वल टू 5. ताने गोटे ऑब्जेक्ट एठी रखिले से ऑब्जेक्ट रो केतेटा इमेज हम ऑब्जर्व करि परिया कहिले दैट 5 नंबर ऑफ इमेजेस. So that these are the different properties of a plane mirror. And now already that we have completed that in the discussion of how reflection is taking place from the surface of a plane mirror, already that we have completed. Now we will take the discussion that how reflection is taking place from a curved mirror, or that is called the reflection taking place from a spherical mirror. So first we should have to know what is your spherical mirror, then how reflection will be obtained from the surface of a spherical mirror, we will take the discussion. Suppose spherical mirror, now we will take the discussion, that is your what about your spherical mirror. Suppose we have taken a hollow glass sphere. It is a hollow glass sphere, and let the outer surface of the hollow glass sphere, that is the color polished. The outer surface is color polished. If the outer surface is color polished, then the inner side, that will be the reflecting surface. এইটা গোটে স্পিয়রতে ଅଛି, গোটে গোলক, ওড়িয়াରେ ଆମେ କହିବା ଏଟା গোটে ଗୋলକ ନେଇଛେ ଆମେ, ଯାର ମାନେ ଇଏଟା ହଉଛି ହୋଲୋ, and it is your hollow glass sphere. Outer surface is the color polished, inner surface is the reflecting surface. Now this is the center of the sphere, and to obtain or to get a curved mirror or a spherical mirror means that only that we have to take a part out of the whole hollow sphere. A total hollow sphere we gote part nova by cutting from the sphere, that we will take a part. Ei kati dele ami mone karo, after cutting or after taking a part, you see here this portion that it will represent to a spherical mirror. And by looking from the reflecting side, that it is observed that the middle point or the center, that is depressed, but the edge, that is bogging like this. এই shape হবো total hollow glass sphere রু তুমি গোটে পিসটে কাটি দেলে এই shape হবো, সেটা মানে গোটে curved mirror. এপট হচ্ছে this side, that is the color polishing surface, and this side, that is the reflecting surface. Now this most depressing point, that it is called the pole of the spherical mirror. But this spherical mirror, it is called the concave mirror. The spherical mirror, that is of two types. One is the concave mirror, another that is the convex mirror. So that spherical mirror means it is a reflecting material which forms the part of a sphere. Gote sphere ro gote part a gote reflecting material heitibo, সেটাকে আমি কহিবা that it is the spherical mirror বলি। ଆଉ ଯୋଉ spherical mirror ଆମେ ଦେଖୁଛେ ତାର ସେଣ୍ଟରଟା ରିଫ୍ଲେକ୍ଟିଂ ସାଇଡ୍ ରୁ ଦେଖିଲେ ତା ସେଣ୍ଟରଟା that is depressed, ଦବି ଯାଇଛି, that spherical mirror, that is called the concave mirror. Now this is your concave mirror, and the most depressing point of this concave mirror or of this spherical mirror, that is called its pole. This point is the pole of the concave mirror or pole of the spherical mirror, and this is the center. जो स्फीयर रु हम गोटे पार्ट नैतिले एटा होता सेंटर, सेटा हबो ए कनकेव मिरर रो सेंटर ऑफ कर्वेचर. सी हला सेंटर ऑफ कर्वेचर, पी हला पोल ऑफ द कनकेव मिरर, सी हला सेंटर ऑफ कर्वेचर ऑफ द कनकेव मिरर, एंड नाउ सी टू पॉइंट पी पॉइंट रे जॉइन करले जो लेंथ रा होची एटा होची रेडियस ऑफ कर्वेचर ऑफ द गिवन कनकेव मिरर आर. आर ता होची रेडियस ऑफ कर्वेचर, सी हला सेंटर ऑफ कर्वेचर, पी हला पोल. And now again, by drawing a line passing through the center of a curvature and the pole of the given concave mirror, that is called its principal axis. This line is called its principal axis. So that you see here, C center of a curvature, P that is the pole, R capital R that is the radius of a curvature, and again another point for this concave mirror that you see here, the middle point between C and P, this point is called its focus. F point hela focus of the given concave mirror, and it is the middle point of C and P. এই পয়েন্টটা যদি ফোকাস হইতিব এই কনকেভ মিরর র, তাহলে ফোকাস পয়েন্ট রু পোল যাকে যে লেংথটা হলা, ইট রিপ্রেজেন্টস টু দ্য ফোকাল লেংথ অফ দ্য গিভেন কনকেভ মিরর. তাহলে এইটা যদি মিডল পয়েন্ট হুয়ে, সি আউ পি র মিডল পয়েন্ট, এইটা যদি স্মল এফ ডিসটেন্স হবো, তাহলে এইটাই হবে স্মল এফ. तामाने c रू p जाके लेंथ बा डिस्टेंस होची r and that is also equal to f plus f. It is the middle point. Capital F is the middle point. So that if it is f small f, it is also small f, then the total distance from c to p that it is equal to 2l or twice f. तामाने it means that r is equal to 2l. Or we can tell here f equal to r by 2. Or the focal length that is equal to the half of the radius of curvature, or the radius of curvature that is twice of its focal length. So that this is about your concave mirror. And another term also, since the concave mirror that is observed like this, हमें concave mirror टा देखिले यही टाइप रो लागे, आउ ता edge टा होची circular. तो ये circular outline में जो टा diameter होगो, से diameter टा को हमें कही बाये mirror रो aperture. This represents to the aperture. Suppose that this point is M, this point is N. Mn that represents the aperture. So that the spherical mirror that is of two types. One is the concave mirror, another that is the convex mirror. So that this is about your concave mirror. Now that we will take the discussion that about your convex mirror. In case of the convex mirror, that the inner surface of the hollow glass sphere that should be color polished. Then we have taken a hollow glass sphere and the inner surface that is the color polishing surface, and this is the center of the sphere, means it will also represent to the center of a curvature of this curved mirror, or and here this is curved mirror that it is called the convex mirror. A curved mirror that we call convex mirror, by looking from the reflecting side the center is bogging uthi podichi like this. এই টাইপের হয়েছে এপটু দেখিলে উঠি পড়িছি যেটা সেটা কনভেক্স যেটা দবি যাইছি সেটা হলা কনকেভ তাহলে এইটা আমরা দেখিবা দিস ইজ দ্য সেন্টার অফ কার্ভেচার এন্ড দ্য মোস্ট বগিং পয়েন্ট দ্যাট ইট ইজ কল্ড দ্য পোল অফ দ্য কনভেক্স মিরর এন্ড হিয়ার দিস ইজ দ্য রাডিয়াস অফ কার্ভেচার অফ দ্য গিভেন কনভেক্স মিরর এন্ড দিস লাইন দ্যাট ইট উইল রিপ্রেজেন্ট দ্য প্রিন্সিপাল অ্যাক্সিস এন্ড হিয়ার দিস ইজ योर অ্যাপারেচার আই মিন কনকেভ মিরর কে जोड़ा ड्रॉ করিছিলে. And C out P rotiki middle point hochi that it is the focus. This point is the focus or principal focus, and the distance or the length from focus to the pole that it is the focal length is smallest. Clear na? So that this is your pole, this is the center of a curvature, and this is the principal focus. Capital R that is the radius of a curvature, and a small f that is the focal length. And here Mn that it will represent to the aperture of the given convex mirror. So that totally this was that about your concave mirror and also the convex mirror. Clear na? So this was that about your spherical mirror, and also another important term or important discussion that in the reflection or a reflection of light, that's your mirror formula. Mirror formula. And a mirror formula that 1 by u small u, 1 by v small v equal to 1 by f small f. This is your mirror formula. And out of all the u, v and f, u that it represents the object distance, v that represents to the image distance, and a small f that represents to the focal length. u, v, f जदि गोटे पर्टिकुलर आम ऑब्जेक्ट कोठी रही बोले आम गोटे मिरर पाखे देछि क्वेश्चन रे आ फोकल लेंथ देछि पचारुछि व्हाट इज द पोजीशन ऑफ द इमेज ता माने जदि v टा कैलकुलेट करिया को अछि u देछि f देछि v पचारिछि कोडे क्वेश्चन दैट इज और इन ए न्यूमेरिकल प्रॉब्लम देन दैट यू हैव टू अप्लाई दिस फार्मूला दैट इज योर मिरर फार्मूला 1 by u plus 1 by v equal to 1 by a. So that this is that totally that expression that about your mirror formula. And now this mirror formula that it can be derived by using the spherical mirrors. But before taking the discussion that about the derivation of that is your mirror formula, we have a number of points that fundamental points which that we should have to know, which is your sign conventions. sign conventions. Before taking the discussion that about the mirror formula and also its derivation, we should have to know the sign conventions. Sign conventions means here, suppose that this is your concave mirror and this is the principal axis. It is the pole of the concave mirror, and you see here, this point is the center of a curvature, this is the position of a focus. This is the figure for concave mirror. And a sign conventions means that you remember only that you have to remember 5 points that in sign convention. The first point that here, all the rays of light, number 1, all the rays of light should be drawn from left to right. ଯେତେବେଳେ ବି ଆମେ ରେ ଗୁଡାକ ବା ରେ ଅଫ ଲାଇଟ୍ ଗୁଡାକ ଡ୍ର କରିବା ସବୁବେଳେ ଲେଫ୍ଟ ଟୁ ରାଇଟ୍ କୁ ଡ୍ର କରିବା. ଇଟ୍ ଇଜ ନମ୍ବର 1. Number 2, all distances to be measured from the pole of the spherical mirror, either concave or convex, that as origin. ଯେତେ ସବୁ ଡିଷ୍ଟାନ୍ସ ଆମେ ମେଜରମେଣ୍ଟ କରିବା ଅବଜେକ୍ଟ ପର୍ଯ୍ୟନ୍ତ ହଉ ଇମେଜ ପର୍ଯ୍ୟନ୍ତ ହଉ ସବୁ ଡିଷ୍ଟାନ୍ସ ଗୁଡାକ ତମେ P ପଏଣ୍ଟ ଟୁ ମେଜରମେଣ୍ଟ କରିବ. ଏଟାକୁ origin ଭାବିକି. It is number 2. And number 3, the distances measured towards left are taken as negative as per the coordinate system. जेते डिस्टेंस सब पोल को हम लेफ्ट टू मेजरमेंट करिबा सब डिस्टेंस का नेगेटिव लिया जीवो आ जेते डिस्टेंस हम मेजरमेंट करिबा फ्रॉम द पोल टुवर्ड्स राइट आर टेकन एज पॉजिटिव. लेफ्ट को जेते नेगेटिव राइट को होची पॉजिटिव. एंड इट इज योर नंबर 3. Number 4, distances measured in upward are taken as positive and the distances measured in downward are taken as negative. Right को positive, left को negative, upward hele positive, downward hele negative. So that this is your number 4. Number 5, the principal axis of the spherical mirror, either for concave or convex, should be coincide with the x axis of a coordinate system. गोटे कोऑर्डिनेट सिस्टम रे हमें एटा बुझाई x x डैश इट y y डैश एटा होची ओरिजिन. तेनु जो प्रिंसिपल एक्सिस ता हमें ड्रा करिबा स्फेरिकल मिरर रो सेटा गोटे कोऑर्डिनेट सिस्टम रो x एक्सिस सहित कोइंसाइड होबा दरकार. ता माने प्रिंसिपल एक्सिस ता ग्राउंड सहित बा सरफेस सहित पैरेलल होबा दरकार. So that these are the 5 points in sign conventions, and these points that it will help for the expression or to solve a numerical problem, or it will help to the mirror formula 1 by E plus 1 by V equal to 1 by A. So that this much. Thank you.